Hello, my name is Andrew, and today we will be going over a problem from video assignment number 1. In this problem, it gives us a function. F of x and y is equal to 5 minus 2x squared minus 2y squared. The first part of the problem asks us to calculate a vector perpendicular to the level curve of f. So what we're going to do to find a vector that's perpendicular to the level curve is to find the gradient of f at that certain point. So we have our function again right here. F of xy equals 5 minus 2x squared minus 2y squared. And we want to find the perpendicular vector at the point negative 1, 1. To do this, we will take the gradient of f, which is multiplying the partial derivatives by their vector components. So to do this, we'll take gradient of x and y, and that will be the partial derivative with respect to x, so negative 4x, multiplied by the vector component corresponding to that. And then also add the vector component of y, sorry, the partial derivative of y times the vector component of y. And they want us to find this at the point negative 1 comma 1. So we will just substitute these points into the function. And then negative 4 times negative 1i minus 4 times 1j, and this will equal 4i minus 4j. I'm so sorry for that problem. The point was negative 1 comma negative 1. So we'll get 4i plus 4j as the perpendicular vector. And then they want us to draw the level curve of f at that point and indicate the direction of the perpendicular curve, the perpendicular vector. Okay, so we will be making a contour diagram at an unknown z value. So to find the z value for this, we're going for f of x. We're going to solve for f of negative 1, negative 1, so we can find what z value we're drawing at. So this is going to be 5 minus 2 times negative 1 squared minus 2 times negative 1 squared. And this will equal 5 minus 2 equaling 1. Okay, so now we will go and draw a nice little graph. Label our x and y axes. And we want to draw the graph of the function 1 equals, 1 is from here, solving for z, 5 minus 2x squared minus 2y squared. So this function can be rearranged. We can put the 5 over this side. So the new function would be negative 4 is equal to negative 2x squared minus 2y squared. And divide everything by negative 2, leaving us with 2 equals x squared plus y squared. This function is the same as that of a circle with a radius of 2. So that's what we will draw. Okay, so a radius of square root of 2. Sorry if I misspoke. That's going to be, we have points at 1, 1, negative 1, 1, here and here, and then approximately there, just to plot them out and draw a nice circle like that. And then they want us to, we should really label this as z equals 1. And then we should draw the perpendicular vector starting from the point negative 1, 1, and going in the direction of the perpendicular vector, which is this right here. So that is going 4 up, so 1, 2, 3, 4, and 4 across. 1, 2, 3, 4. So that'll be like that. That is our vector v. The next part of the question wants us to understand the local behavior at one point. Sorry, after understanding the local behavior, draw at least 3 different level curves of f of x and y over a wider range. And they want us to clearly indicate the curve with the corresponding level. So we will go down here. One, two, three, four. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Label. So we already have this one curve with the radius equaling square root of 2. We can draw this sideways. Z equals 2. Yeah. And then we can also draw some other variables or other values of z. So let's say that, I'm sorry, I misspoke. Z equals 1. So we can draw this for other values of z. So I will say, let's do this for a value of -3, -5, and -7. And if we each plug those into this function, just as we did with this one right here, we will rearrange. We get, in this one, we get -8 on this side, and divide by -2, we get 4 is equal to x squared plus y squared. Here on the second function, so let me just box that. In the second function, we will get 10, so that's 5, equals x squared plus y squared. And if you see the pattern, x squared plus y squared, it's just going to be an increasing radius if you solve for z equals this value. So we will go ahead and plot those. You got a radius of the square root of 4, so that's going to be 2's. I'm going to draw a circle with the 2 values. Z equals -3. Then we have a radius of square root of 5. That will be just above this other circle that we just drew. And then z equals the square root of 6. This is also going to be quite a tight drawing, but all within the little boundary. So z equals -7. And that is 3 other contour diagrams of a function. The next problem wants us to calculate a vector perpendicular to the surface, z equals f of x and y, at the point -1, -1, 1. Sketch the surface plot near this point and show the direction of the perpendicular vector. This will help you connect how level curves translate to the 3D surface. Okay, so for this, we will be finding the same perpendicular vector as we did in the first. However, it will be in 3D. So in order to do this, we have the function z equals 5 minus 2x squared minus 2y squared. In order to make this a function of 3 variables, we have to move this z to the opposite side. So our new function of x, y, and z will be 5 minus 2x squared minus 2y squared. Okay? And to find the perpendicular vector, we will do the same thing as we did in the first problem. We find the gradient of f of x, y, and z, which is just the partial derivatives times their corresponding vector components. So, forgot my minus z there. We will take the partial derivative with respect to x. We will get -4x times I minus 4y times j. And since the z is just 1, it is just 1k. just like that. And then it wants us to find it at the point -1, -1, 1. So you'll go ahead and just plug these numbers in, notate it right. The gradient of -1, -1, 1, -4 times -1, I, minus 4 times -1, j, minus, there is no place to put the z variable, so that just leaves as 1k. Simplify this, we get 4i plus 4j minus 1k. And they also want us to sketch this in 3D. So I will be attempting to draw this in 3D as best as possible. So the x squared plus y squared, or sorry for speaking, the negative x squared minus y squared takes the shape of roughly a bowl starting at the origin, just like that. So this one will do almost the same. It will start higher and go down a bit steeper than the original bowl because the x and y have coefficients greater than 1. So this is basically what our, x is here and then y is here. Yeah. This is basically what our 3D graph would look like. And we want the point -1, -1, 1. So that's going to be approximately somewhere over here on the opposite side of the graph. And it's going to go +4 in the x direction, +4 in the y direction, and -1 in the k direction. So that vector is going to go, just draw this out in red, +4, +4, -1. So this is our final vector, which is perpendicular to the surfaces, to the surface at that point. Next, we're done with part C, so we want to go to part D. To see how the entire surface behaves, sketch the full 3D surface, z is equal to f of x and y, and highlight how level curves in part B correspond to the surface at different heights. This connects to the 2D contours of the 3D surface geometry. So we already did this, but I will redo it again. We will draw a little 3D graph right here as best as we can. This is z, this is x, and this is y. And again, we'll start somewhere higher and slope down a bit faster than the traditional bowl. And then these circles, even though I'm drawing them strictly for visualization purposes, would actually be the same circles that we see in this part of the graph right here. So if we look at this graph right here, and we decide to tilt it towards us this way, we will get that the z-axis goes toward us, right? So this is the z-axis, and we have the y-axis going this way, and then the x-axis going this way. And if you just turn this, oh, okay. If we just turn this around 90 degrees this way, we will get those same circles as we saw in the original graph over here. So that is it for part D. Now, part E wants us to consider the gradient vector at -1, -1, and say its relationship to the tangent path at the point -1, -1, 1. That point's uphill. Okay. So it wants us to connect the relationship between the 2D perpendicular vector and the 3D tangent vector. Okay, so if we utilize the same strategy as we saw in part D, the rotating of the axes to make it appear as 2, we can see, well, we know for a fact that this tangent vector is somewhere on the edge of this graph, and it's going to go this way, right? And then the previous answer we had was a vector perpendicular to the surface going that way. So if we use the same trick, we can just rotate this graph right here in order to make it look exactly the same like this one, except from the top being a different view. So we can conclude that if this graph has the same x and y as this one, when it's from the top, then the vector, the 2D vector, and the 3D vector, so this is the tangent, and this is the perpendicular, will have the same I and j components. So, yeah. And the next part will have us find the, it will have us find the perpendicular vector to the surface and the tangent vector to the surface. So the perpendicular vector to the surface is the same thing we did right here in part C. We're going to redo it down here, part F. So the function z is equal to 5 minus 2x squared minus 2y squared. We'll move that over. Big function of f of x, y, and z equals 5 minus 2x squared minus 2y squared minus z. Then we take the gradient of the function, and this will give us the greatest rate of change. So negative 4xi minus 4yj minus 1k. And then we will plug in those same values. Yeah. Negative 1, and 1. So we will do it at negative 1, and 1. We already solved for that earlier, so I'm just going to skip some steps here. 4i plus 4j minus 1k. Okay, so this vector is going to be pointing that way, right? Towards the inside, because it's a negative k value. Or, sorry, it's going toward the middle of the function, as we saw in the 2D graph right here, and then downwards because it has a negative 1k value. And what we notice about the function of the perpendicular and tangent is that they are perpendicular to each other. So notate this right. This is vector n right here. So vector n is perpendicular to vector t. And what we know that vector n has the same n values as the 2D vector right here. And that has the same has the same x and y values as the tangent vector in here. So we conclude that n is equal to 4i plus 4j minus 1k, and that t is also equal to 4i plus 4j with some unknown k value. We'll call that z1. So our goal is to find this vector t, which is the tangent to the curve of steepest ascent. So what we know about vectors is that the dot product of two vectors is 0 when they are perpendicular to each other. So the dot product of n and t must equal 0 because they are perpendicular to each other. So we will do this by multiplying them next to each other. So 4i plus 4j minus 1k and then 4i plus 4j plus z1k. This is n. This is t. To do the dot product, just multiply downwards. So we get 16 here plus 16 here minus z1 here. Yes. And we know that must equal to 0. So, solving for this equation, z1 is equal to 32, and we get that the vector t is equal to 4i plus 4j plus 32k, which looks about right because it's skyrocketing upwards right here. And that is it for the problem for the video assignment. Thank you so much. Have a great day.